Hello everyone. So today we're going to be working out of the textbook. So the section here is 6.3, Solving More Systems, and the title is What's for Lunch? Okay, so I'm going to demonstrate how to do problem 1, which is going to be extremely similar to problem 2. And you're going to do problem 2, okay? So follow along and you'll get all of problem 1 done. Okay. So it says Constance owns a small lunch cart. She changes her menu daily. Yesterday she offered a chef salad for $5.75 or a hoagie for $5. She sold 85 lunches for a total of $464. Determine how many chef salads and hoagies she sold. So you know right off the bat that the important information is probably going to be right here. Okay? That's probably what we need. So number 1 says, write an equation in standard form that represents the total number of lunches in terms of the number of chef salads sold and the number of hoagies sold. Let X represent number of chef salads sold and let Y represent the number of hoagies sold. Okay, that sounds a little confusing, but I think we can get it. So if you forgot, standard form is AX plus BY equals C. That's standard form, okay? So it says here, write an equation in standard form to represent the total number of lunches. So number of lunches sold was right here. 85 lunches. Let X represent the number of chef salads and let Y represent the number of hoagies sold. So X is chef salad. X equals chef salad and Y equals hoagies. Hoagies. Okay. So in that case, if X is chef salads, let's just write X, and we're going to follow the standard form. X plus Y represents hoagies equals, it says number of lunches sold. So this is the tricky part. Are we going to do the 85 lunches or are we going to do the $464? So that's where people might get confused. But what you're going to do is you're going to put down the 85 lunches because it even tells you here total number of lunches. Okay? There you go. There's your answer for number 1. Okay? So I'm going to move this briefly so it doesn't get in the way. Okay? Number 2, write an equation in standard form that represents the amount of money collected. Use the same variables as those used in question 1. Okay? So this one should be easy. How much are the chef salads? $5.75. So if we know chef salads are X, as we wrote down here, hoagies are Y. How much is the chef salad? $5.75, right? $5.75 X plus how many hoagies? $5 for a hoagie. I'm just going to put 5. 5Y equals, so now that we're talking about money and we're writing things in terms of money, we're probably going to use, I'll erase that one. We're going to use now this figure here. 464. Okay? So we have $5.75 for every 1 chef salad, which is X, plus 5 hoagies, or $5 per hoagie, and these are the hoagies here. You add those up, it should give you $464. Okay? So number 3, write a system of linear equations to represent this problem situation. Okay, easy question. So remember that a system of linear equations is basically just both equations that we just wrote down. So we have 1 right here, and we have 2 right there. And let me try to write this a little neater. X plus y equals 85, and 575 plus 5y equals 464. Okay? So there's your system of equations. And again, system of equations are just two equations that are related to each other. So in this scenario, we have our first equation for number 1 and our second equation for number 2. Okay? Number 4. What methods can you use to solve this system of linear equations? So you can, basically telling you how can you solve this. You can use any method. You can use substitution. Substitution. I hope I spelled that right. We can use elimination. And our old favorite, graphing. But graphing in this case is more work. Okay? So those are the 3 methods we can use. Number 5, determine the solution of the linear system of equations by using linear combinations, then check your answer. So they want you to use linear combinations, which we said in previous sections is the elimination method. I will let you solve these problems any of the 3 methods that is easiest for you. Okay, with the exception of like those cheating applications. Well, they're not cheating, they're helpful, but you need to know what you're doing for the test and for the quizzes. So elimination, let's go ahead and do that. So we probably need more space. Let me see if I can try something here. Copy. Oh, it worked. Cool. Okay, so we're gonna basically solve for x and y. Solve for x and y. I'll write this a little bigger. X plus y equals 85. 575x plus 5y equals 464. Okay? So the first thing I would do, because it's just easiest, I would get rid of the y's. Okay? So if it's 5y right here, positive 5y, what's the opposite of positive 5y? Negative 5y, right? So I'm going to go ahead and multiply this equation here by negative 5. Okay? We're going to distribute, and you're going to get negative 5x minus 5y equals, I have no idea what this is, 85, 5, 25 to 42. It's negative 425. Okay? And now we're just going to add across. And I'll cross this out. Well, yeah, I'll cross it out a little bit, just so you guys don't look at it anymore. Okay? So now let's go ahead and just add downwards, okay? 575 take away 5. If that's a tough number, think of it in terms of money. $5.75. Take away $5. How much do you have left? 75 cents. 0.75x. And here we go. Positive 5y take away 5y is 0. So I'm just going to plus 0 equals, I don't know. Let me see. 464 minus 425. We're going to borrow 5, 1, 9, 3. 39. Okay? So, I'm just going to rewrite it, make it look a little nicer. Equals 39. Now you're going to divide by 0.75, 0.75. X equals 52. Okay? So that's our first answer. X equals 52. And now I'm going to put my answer here. Now, let's go ahead and plug that 52 back into the original equation. And let's plug it into this first one right here. Plug it in right there, okay? X plus Y equals 85. X plus Y equals 85. We're going to plug 52 in for X. 52 plus Y equals 85. Subtract 52 to both sides. I want to isolate the variable and get it by itself. So that just drops down the Y. Y equals, let me see, 33. And there you go. Y equals 33. And this is all the work. Yes, you can use another piece of paper to show all your work. That's perfectly fine. And let's do that little trick again. Copy. Whoa. Took more than we wanted. That's okay. So, according to this problem, what does this mean? Just move it a little bit. So what this problem is saying is that X is 52, Y is 33. So remember, X is chef salads, right here, and Y is hoagies. That means that in order to add up to $464 with these prices, that means that they sold 52 chef salads and 33 hoagies, which is realistic if you think of like a restaurant that in a day they could sell that many. And so that's a real answer. You know, if you would have got like 1 million something in one day, I don't know. It's a little different, but these are reasonable answers. Interpret your solution to the linear system in terms of this problem situation. So I kind of just said it, but I'll write it. Constance, I forgot she had a name, sold 52 chef salads and 33 hoagies. And there you go. That's all of problem 1. So you have all the work. The work was on the other slide, which you can just do on another piece of paper or on the back or something. And there it is. So what you're going to be responsible for is problem number 2. It has some fractions in it, but it's not that difficult. It's the same thing. You could turn the fractions into decimals. So a little heads up. Half could be turned into 0.5. 3/4 could be turned into 0.75. Okay? Okay. Yeah, it's about the same thing. Actually, I think it's easier. Yeah, it's about the same. Alright, guys. Good luck.